Welcome to a lesson on Webster method, and we are the group 4. So here are some learning objectives that you need to learn about Webster method. First, you need to explain the purpose of Webster method and its relevance in specific problem-solving scenarios. Second is describe the basic concept and principle behind Webster method, including its history and significance in fields like mathematics or voting system. Third is define the terms related to Webster method such as quotient, divisor, proportionality, and rounding. Fourth is outline the step-by-step process of applying Webster method from the initial calculation and final result. Fifth is work through sample problems that demonstrate the practical application of Webster method. Sixth is solve example problems using Webster method, showing all necessary steps and calculations. 7 is interpret the results of the calculations and explain the meaning behind the outcomes, especially how they reflect proportionality in representation or distribution. Lastly is summarize the effectiveness of Webster method compared to other rounding and allocation methods. The introduction of Webster method is Daniel Webster proposed a method similar to Jefferson in 1832. It was adopted by Congress in 1842 but replaced by Hamilton method in 1852. It was adopted again in 1901. The difference is that Webster rounds the quotas to the nearest whole number rather than dropping the decimal parts. If it doesn't produce the desired results at the beginning, he says, like Jefferson, to adjust the divisor until it does. In Jefferson's case, at least the first adjustment will always be to make the divisor smaller. That is not always the case with Webster method.
Daniel Webster, a prominent American statesman, proposed an apportionment method in 1832 that was later adopted by Congress in 1842 and readopted in 1901. His method is similar to Thomas Jefferson's, but with a key difference in how quotas are handled. While Jefferson's method rounds down quotas removing the decimal, Webster's method rounds to the nearest whole number. If the initial calculation does not yield the desired number of representatives, Webster suggests adjusting the divisor, which either increasing or decreasing it, until the correct number of representatives is assigned. This contrasts with Jefferson's method, which always reduces the divisor to adjust. This flexibility distinguishes it from Jefferson's more rigid approach. In summary, Webster's apportionment method enhances fairness and accuracy in representation.
Here are the definition of terms and Webster method. The Webster method is a technique used for apportioning representatives among states based on populations. It aims to provide a fair distribution of seats by using a specific rounding approach. So there are 5 key terms of Webster method. First one is quota, the theoretical number of representatives a state should receive, calculated by dividing the state's populations by a divisor. Second is standard divisor, the total populations of all states divided by the total number of representatives. It represents the average of number of people per representative. Third is modified divisor, an adjusted divisor used to ensure that the total number of allocated seats matches the required number. This may involve tweaking the standard divisor. Fourth is rounding. In the Webster method, quotas are rounded to the nearest whole number, which can affect the final allocation of representatives. The last one is apportionment, the process of distributing a fixed number of representatives among states based on their populations, ensuring equitable representation.
The steps and procedures. First things first is to determine how many people each representative should represent. Do this by dividing the total population of all the states by the total number of representatives. This answer is called the standard divisor. Next is to divide each state's population by the divisor to determine how many representatives it should have. Record this answer to several decimal places. This answer is called a quota. Next is to round all the quotas to the nearest whole number, but don't forget what the decimals were, and add up the remaining whole numbers. Lastly, If the total from step 3 was less than the total number of representatives, reduce the divisor and recalculate the quota and allocation. If the total from step 3 was larger than the total number of representatives, increase the divisor and recalculate the quotas and allocation. Continue doing this until the total in step 3 is equal to the total number of representatives. The divisor we end up using is called the modified divisor or adjusted divisor. And thus, this adjustment continues until the total matches the desired number of representatives, ensuring fair and proportional representation.
So here is the sample problem. The legislature in a state has 44 seats. Apportion these seats to the 5 counties below using Webster method. So in order to get the standard divisor, we need to total all population, then divide it by 44, which it is the 44 seat. So we got 1,582,000 population, then divide it by 44. We got 35,954.5455. So to find the quota, we need to divide the population and the standard divisor. So 365,000 divided by 35,954.5455. So we got 10.152. We do the same for the remaining counties. In order to get the initial, we just need to round up the quota. Adam got 10, Grant got round up, so it's 14. Colton has 7, David got 5, Hayes got also round up, so it's 8. Then we total all of it. 10 plus 14 is equals to 24, plus 7 is equals to 31, plus 5 is equals to 36, plus 8 is equal to 44. So we got 44, the number of seats that we have to apportion. So our initial allocation is also our final apportionment.
The interpretation or answer is that the goal of Webster method is to assign legislative seats as fairly as possible by rounding quotas to the nearest whole number. In doing so, it minimizes the bases that may favor larger or smaller states. The steps to apply this method include calculating the quotas, rounding them, and adjusting the divisor when necessary to ensure that the sum of the assigned seats equals to the total number of representatives. By modifying the divisor, one can increase or decrease the representation of states proportionally, which makes Webster method flexible and equitable. For example, if a state legislature has 44 seats and 5 counties, each country's population is divided by the standard divisor calculated from the total population and the total of seats, if the sum of the rounded quotas doesn't match the 44 available seats. Adjustments to the divisor are made to achieve the correct allocation. The final adjusted divisor ensures that apportionment is both accurate and fair. In short, the Webster method is flexible and equitable method for allocating legislative seats by rounding population quotas to the nearest whole number, ensuring fair representation for all countries.
Here's the conclusion or generalization about Webster's method. Webster's method of apportionment strikes a balance between fairness and flexibility, ensuring that representation is as proportional to population as possible. The method's strength lies in its use of rounding and the ability to adjust the divisor. This makes it particularly useful in cases where quota do not neatly sum to the total number of representatives. So, Webster's method of apportionment effectively balances fairness and flexibility by ensuring that legislative representation closely align with population size. Its strength lies in its unique rounding technique and the capacity to adjust the divisor, making it especially beneficial in situations where population do not perfectly match the total number of representatives needed. Webster's approach provides a more balanced distribution compared to Jefferson's method, which tends to favor large states. By rounding to the nearest whole number and adjusting the divisor when needed, Webster's method achieves a more equitable and precise allocation of seats across different regions. In short, Webster's method achieves a more balanced seat distribution than Jefferson's, which favor larger states by rounding to whole numbers and adjusting the divisors. It ensures a fairer allocation across regions.